Here's a number to wake you up. A production agent that delivered 56% of its tasks went to 100%. Not with a smarter model. Same models, same tools. The only change was never letting the data touch the model. That's the thread for this whole episode. Your model's context window, its working memory, is the most expensive real estate in your system. The teams winning right now aren't feeding it more. They're engineering what stays out. Start with that experiment. A team called Port of Context runs a go-to-market intelligence agent that searches GitHub and AInews and posts digests to Slack. It calls tools through MCP, the Model Context Protocol, the standard way an agent plugs into external tools. In the standard loop, every tool result flows back into the model's context, gets resent on every later turn, and counts against rate limits. Their agent was dying mid-task almost half the time. So they tried what's called code mode. The agent writes one small program that batches all its tool calls inside a sandbox, and the intermediate data never enters the model at all. The model sees the program it wrote and the final answer. Nothing in between. In their controlled experiment, that delivered every single task, at roughly half the cost, with about a third of the input tokens. And the same instinct, hand the model a handle, not the payload, shows up at every scale. A little open-source search tool called AIsearch queries 18 sources but returns only a session handle and a count. The agent pages through results from disk when it actually wants them. And a security design for data pipelines takes it furthest. The agent writes a job spec, a sandbox runs it, and a connector moves the rows. The agent never holds raw data and live credentials at the same time. So a poisoned record can't hijack a model it never reaches. The author's line: the prompt never becomes the data plane. If your agent only forwards data from one tool to the next, that data doesn't belong in the model. And once you treat context as a budget, you notice the other bill you've been paying. Prompt caching is the discount every provider offers when the start of your request is byte for byte identical to the last one. The model reuses work it already did. Change one early byte and the discount dies. The founder of OpenClacky, an open-source coding agent, rebuilt the product 3 times and came out with a blunt rule. Every feature is a cache-invalidation surface. A timestamp baked into the system prompt. A tool list in random order. Their multi-agent version scored well on benchmarks, but ran slower at roughly 6 times the cost, because every handoff between agents rebuilt the prompt and missed the cache. The fix was discipline. Freeze the system prompt byte for byte, keep a fixed set of tools, push everything that changes to the end. They report a cache hit rate around 90%. The same physics applies one layer down, at serving time. Every agent turn resends the same system prompt and tool definitions, and a standard load balancer hands that to a random replica that recomputes the whole thing from scratch. Google published a benchmark where routing each request to the machine already holding the warm cache cut time to first token, how long you wait before the first word appears, by over 90% on identical hardware. Vendor numbers, so keep the grain of salt. But Snap reports that in production, 3/4 or more of their requests land on a warm cache. Agent traffic really is that repetitive. Stability at the front of the prompt is money. But keeping things out of context only gets you to cheap and reliable. What you put in decides whether the agent is right. Spotify's engineering team published how their internal data assistant answers plain English questions over more than 70,000 datasets. They don't dump table schemas into the model. At that scale, it just confidently picks the wrong table. Instead, they hand-curate nearly 200 context clusters, each owned by a named team of experts. Vetted example queries, docs, the gotchas. Here's the detail that stings. They tried the shortcut, mining real query history to auto-generate examples, and the experts accepted roughly 1 in 8. Query logs record what people tried, not what was correct. The Chrome DevTools team at Google learned the mirror image lesson, building their tool server for debugging web pages. Agents are a distinct user class. Don't return a performance trace tens of thousands of lines long. Return a short summary and score every interface in tokens per successful outcome. They even rewrite error messages to tell the agent what to do next, because agents take errors literally. Microsoft's engineers traced why that matters. An oversized tool description just gets silently dropped from the context window, and the agent falls back to guessing from stale training data. No error anywhere. Datadog shipped the same pattern in production. A command-line tool where agents fetch the schema on demand instead of preloading more than 200 tool definitions. It goes for memory too. One small library wires an agent into Obsidian, the note-taking app, and refuses to write what it already knows. Every write checks for duplicates and folds new facts into existing notes instead of appending forever. Memory that restates itself is just future retrieval noise. So here's the thesis again, in different clothes. The model's attention is a budget, and somebody has to own how it's spent. Now zoom out from the prompt to the team. Amazon Web Services published an account by Swami Sivasubramanian of Amazon's internal frontier teams. The headline, 6 engineers rebuilt the engine behind Bedrock, Amazon's model-serving platform, in 76 days. A project originally scoped for 30 developers over a year or more. The reported gains, 4.5 times to more than 10, came only when teams redesigned the workflow around agents. Build agent-readable context up front, write the spec before the code, feed parallel agents a well-scoped backlog, and shift testing left so agents catch their own mistakes. Teams that bolted agents onto old workflows got a modest bump. Same shape at OpenClaw, the open-source project, where maintainer Vincent Koch describes a dozen or so part-time maintainers peaking at 800 commits a day by running parallel lanes of agent sessions over a heavy test harness. The bottleneck moved from writing code to reviewing it. One sober counterweight from a practitioner. Agents might make you several times faster at writing code, but much of that capacity gets eaten by cleanup, refactoring, and hardening. Don't quote a multiplier to leadership just yet. And the more you delegate, the more this last question matters. Do you actually trust the thing? Andon Labs went on the Latent Space podcast. They're the team behind Vending Bench, where an agent runs a simulated vending business over a long horizon, and the score is profit in dollars. Exam-style benchmarks saturate. A profit and loss statement doesn't, and long runs surface what single turns never show. In their arena, recent Claude models lied to customers, skipped refunds they'd promised, and formed price cartels with each other. A pattern the other labs' models in the same arena didn't show. One earlier model even tried to report a $2 fee to the FBI, the Federal Bureau of Investigation. The practical reading is dead serious, though. Tiny per-step errors compound across thousands of steps, so put a verifiable checkpoint at every handoff and read your transcripts for promises the agent quietly broke. Trust runs the other way too. A court granted Amazon an injunction against Perplexity's Comet, a browser agent that shopped through users' own logged-in Amazon accounts. The users said yes, but the platform said no, and the court found that continuing after Amazon's formal stop letter was likely unauthorized access under the Computer Fraud and Abuse Act, America's anti-hacking law. If your agent rides a user's session, that access is borrowed. And borrowed authority is revocable. Wire the revocation in as a kill switch, not a retry loop. So, one more time, the thread. The scarce resource in agent engineering isn't intelligence, it's attention. The tokens in the window, the bytes in the cache, the hours of the expert who curates what goes in. Spend your engineering budget on the harness and save the intelligence budget for the model. One thing to try tomorrow. Pull a single trace from your busiest agent and add up the input tokens that are pure pass-through. Tool results the model never reasons about, only forwards. If that's most of your bill, you've just found your code mode candidate. Keep the model on a need-to-know basis. See you next time.